This video is part of the MCAT Chemistry video course. Subscribe and hit the bell if you'd like notifications about the release of new videos, and please visit ancientbrainstutoring.com for questions about one-on-one virtual MCAT tutoring. In this video, we'll talk about rate laws, so we'll first go over what a rate order is, and then how to find the rate law. For everything that we're going to talk about right now, we're using this hypothetical situation of x plus y giving us the product of xy. And then we also have this rate law written down here. And the rate law is what tells you the rate of the reaction. And notice that it's dependent on the concentration of x times the concentration of y. And then we multiply that by this k value, and k is a constant that is dependent on whatever reaction is happening. And then your x and y are each going to be raised to a power. And what we're going to go over now is how you find that power that those two concentrations get raised to. We have three different hypothetical situations here. The first, x is in the 0th order, the next, x is in the first order, and then the last one, x is in the second order. So these would be three different separate hypothetical situations. For each one of these, notice how we have x, and we're changing the concentration of x on the left side of the column, and then we're seeing how does that affect the rate of the reaction. So in this first one, hypothetically, if x was in the 0th order, notice how when we change the concentration of x, we are doubling it. So we go from 0.5 to 1, from 1 to 2, and then if you look at the rate of the reaction, it's not changing. So anytime that you change the concentration of a reactant, but then the rate is unchanged after you change the concentration, then we say that that reactant is in the 0th order. So then if you were to write your rate law, you would write rate equals k times x raised to the 0th times y, and then y would have to get raised to whatever order it is in. And we're not going to go over what order y is in. We're just going to use x for our examples here. So if we raised x to the 0th order, what that would equal would just be 1. So the x would just kind of go away, and we would just be left with k times y raised to whatever order y is in. If x was in the first order, so this next table, every time that we double x, so again, we're just doubling x, notice how the rate also doubles. So if you double the concentration and then the rate also doubles, then that reactant is in the first order. So now our rate equals k times x to the first times y to whatever order y is in. And what we're basically doing for our first two, so let's look at the table on the left. We're saying that the reactant is being doubled. So the amount of x is doubling. So let's use 2 for the amount that x, the magnitude that x is going up by. We raise it to the 0 because that is the order that it's in. So then that means that our rate should be going up by a factor of 1. So the rate is unchanged. And then do that same thing for the first order. So again, we're doubling our reactant. So put a 2 to represent that we're doubling the reactant. We are in the first order, so raise that to the first power. So then that means that your rate should also be going up by 2. So then if we use that same prediction for the one on the far right, we are doubling the reactant just like normal. So we write down a 2. We're in the second order, so we put a 2 there. So that means that we should expect our rate to be going up by a magnitude of 4 every time that we double our reactant concentration. And if you look at the table, when we go from 0.5 to 1, our rate goes from 2 to 8. So we double the reactant, but the rate goes up by 4. And then again, when we go from 1 to 2, we double the reactant, but we go from 8 to 32, so the rate goes up by 4 again. So that is what something in this second order would do whenever the concentration of that reactant is doubled. And the rate for that one would be rate equals k times x to the second times the concentration of y raised to whatever the order of y is. Here is a typical way that kinetic problems will be tested on the MCAT. So you're going to be given this experimental data, and then they may ask you to calculate some part of the law. So what we're going to do is we're going to calculate the entire rate law. And then what the test will do is ask you to just do some portion of this calculation. So first we need to find the orders for the reactants. And they're always going to present the data to you in this exact same way. So if you look at this table, we have the concentration of x and the concentration of y. So to find the order of x, we need to look at in what situation does x change but y stays the same, and then see what happens to the rate for those situations. If we look at row 1 and row 2, x doubles but y stays the same. So any change in the reaction rate has to be due to changes in x. So x doubles, and then the reaction also doubles. So 2 raised to what power equals 2? And that would be 1. So for x would be the first order. And then do the exact same thing for y. So for the last 2 rows, x stays the same. It goes from 1 to 1. And then y doubles. And the rate goes up by 4. So for y, the concentration doubles, so you put a 2 there. The rate goes up to 4. So what power would 2 have to be raised to go to 4? That would be 2. So that means that y is in the second order. So now we know that our rate law equals k times x raised to the first times y raised to the second. The final part would be to figure out what k is. And for k, you can pick any line in your table and just plug in those numbers into the rate that you have written down here. So let's pick the last line that we have written because it's got the easiest numbers to work with. So for this one, we have 16 equals k times the concentration of x, which is 1, times the concentration of y, which is also 1. So that leaves us with k equal to 16. So your total rate law would be that the rate equals 16 times x to the first times the concentration of y raised to the second. And finally, the last thing you want to be able to do is recognize what the total order for a reaction is. So if you look at our rate here, the total order would simply be if you add up all the exponents that are in the rate law, whatever those add up to be, that is your total order for that reaction. So the order for this reaction would just be 1 plus 2. So the total order would be 3, so this is in the third order. X individually is still in the first order and y is in the second order, but total, we'd say that this reaction is in the third order. And sometimes you can't have more than 2 reactants. And the same rule applies. Just count your exponents and add them up, and then that's going to be the order that you're in.